Okay, my outstanding friends, this is finally starting to pay off. People are understanding. No antibiotics can help you in certain cases. The only things that can help you are probiotics. That is bacteria. Bacteria in you attack invaders, but it's a good bacteria. If you kill those with antibiotics, you don't have anything to attack the attackers. And they can walk right through you and just destroy you, just like this guy. He was going to die. Virtually no question whatsoever. His wife saved him by finding the slimiest slime they could find. All right, here's her husband dying. And so she heard about phage therapy, which is nothing more than probiotics. And she convinced phage scientists around the country to hunt and peck through molecular haystacks of sewage, bogs, pines, bilge of boats, other prime breeding grounds for bacteria. Now, what were they looking for? Something that would eat other bacteria. They're saying that these things will eat other bacteria, and that's correct. Now, what's happening though when you get sick is you have the same exact thing, only instead of eating the bad bacteria, they eat your good bacteria, and then you can't protect yourself. So she got them to make a cocktail of sewage to save her husband. All right, I don't know how she got this done, because nobody else can seem to get anything done. She says, next, the Food and Drug Administration had to greenlight the unproven cocktail of hope. Scientists had to purify the mixture so it wouldn't be deadly. And just 3 weeks later, she watched doctors intravenously inject the mixture into her husband's body, and that saved his life. He became healthy again. See, she didn't take this story, oh, there's nothing we can do, he's going to die, too bad. Unrelenting perseverance, unbelievable good fortune, glowing tribute to the immense kindness of strangers, a story that just might have saved countless lives for the growing threat of antibiotic-resistant superbugs, maybe even you. Estimated by 2050, 10 million people per year, that's one person every 3 seconds, is going to die from these kind of infections. We have been caught for the last 2.5 years in this terrible situation where viruses have been the bad guy, she said. I'm here to tell you that the enemy of my enemy can be my friend. Viruses can be medicine, and she is exactly right. Viruses are nothing more than bacterial infections that create a chemical cocktail that attacks something. Viruses are nothing more than bacteria, basically. There's good ones and there's bad ones. Do the exact same thing, they create enzymes. Alright, you can read up all you want about viral enzymes. Enzymes are the chemistry sets that do absolutely incredible amounts of chemistry instantaneously. Now, this is all about different types of enzymes and how they affect the body, viral enzymes. And, you know, this gives you a whole range of information about disease, inflammation, all of the different things that viruses can cause and affect. And this is the type of thing we're talking about right here. These are proteins, and they are so elegant, they're unbelievable. And now, they have all of this specific architecture to them, and they come out the same way every time. The number of the molecules shoots out all this big long string, and then it all coils up and winds up and does these things. Now, what does that do? It creates molecular magnetic footprint. Right, so there'll be a magnetic spot here and over 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 here, and there'll be thousands of them. And then another bacteria will come and find this because of its signature. It's like it looks for its signature of magnetism. It finds it, and it has its own magnetobacteria that goes clip. It just grabs right on her and squirts its enzyme into these bad enzymes, bad bacteria basically, and it kills the bacteria that's creating these little buggers. And that's how good bacteria kills bad bacteria. Bad bacteria also kills good bacteria. So you have to have all your ducks in a row to make sure that you're not invaded. You have so much immunological capability. It's just incredible. However, once you lose those enzymes, you're in trouble. And the only way you lose the enzymes is to lose the bacteria. And the way you lose the bacteria is you never had in the first place, or it was killed by some antibiotics or some toxins like burn pits. These guys are all dying from these burn pit exposures. Every bit of bacteria on their body and inside their body was attacked by toxins that they could not overcome, and it eventually killed them. It's like you sitting here in a smoke-filled room all day long, that's coming from batteries and from paint and from feces and from every kind of tires and everything. Every kind of nasty thing you can think of is all over you and in you. Obviously, you're not going to do well. And these guys are in trouble. And what we need to do is get them fixed up. And this woman took her husband and straightened him out. No, by using these bacteria. What they did was they injected him with this slime. It works. And fecal matter transplants that's the bomb now, man. You get a fecal matter transplant and you're getting all new bacteria in you. Where your bacteria may be completely gone or very, very weak, you're getting a young person's good, healthy bacteria in your colon. Now you start processing again. You're breaking down your foods correctly. You're creating enzymes and toxins that affect the bad guys. You're not creating toxins that hurt you. You're creating toxins, yes, absolutely. That's what your immune system is. It's a toxic chemistry set. And things come through and it says, hey, there's a magnetic signature we're seeing. That's what they call COVID-19. Go get the guys and get out there and attack them with your toxins. And that's what happens. Now listen to this. All of our troops are in trouble from the Middle East, this Iraqi Bacter, they call it. Because anytime they get a nick or a cut, they get invaded by these things. They're all over the place. Veterans that get shrapnel in their legs and bodies from IEDs, and then they never get better because they can't get rid of this deadly bacterium. And most of them didn't survive. And now they're all dying at home because they can't respond to invasion. It's just like taking tons and tons and tons of antibiotics, which means toxins that kill the biotic stuff that's living in your body. It's really as simple as that. Now we're going to watch this video that she did. I haven't watched it yet, but I'd like to see it and see what she has to say, because she took the bull by the horns and she said, nope, you're not dying. We're going to straighten you out. And I have had a ton of success. I've been doing this 5-6 years now, the antibacterial probiotics. And trying to discover, I don't prescribe anything, I'm not a doctor. All I do is gather information. And I'm telling you right now, probiotics and fecal matter transplants, that'll save lives like you wouldn't ever believe, and make people healthy and happy. Families and these veterans that go off to do our wars, they're going into areas nobody's ever lived, we don't go to. And we don't have any defenses for their things. Let me just tell you a story about my niece. I was just at a thing the other day, and they were talking about my niece who went to Canada, of all places, twice. And when she went there, her lips, just her lips, swole up like gigantic balloons and started getting festered and all cracked and bloody and everything, and just her lips. And when she came back out of Canada, she was okay. Now I looked into this and I can't find anything other than the fact that she had a allergic reaction. What is an allergic reaction? Something attacked her. And what attacked her is only attacking the type of tissue that is in your lips. And your lips are different than any other tissue in your body. The same with your eyeballs. The same with your intestines. The same with every organ in your body. Different tissue, different chemistry, different pH. Everything's different. So the bacteria that gets there may just attack your pancreas. So you got, yeah, the guy's got pancreatitis or whatever they call it. Well, another guy's got lung infections. Another guy's got irritable bowel syndrome. You're all going to have all kinds of different attacks. Now let's just see what she has to say. I know I'm running a little long at this, but this is something I've really been following for a long time, and I was tipped off to this by a friend of mine who was going to die. And they told him there's nothing they could do for him. It was just, they had given him so many antibiotics and nothing worked. And they said, you're being attacked by your own body and we can't help you. And he took antibiotics. 2 weeks later, he was out jogging. And that's just going to be probably the same story with her husband. And it's the same story with a lot of people that I talk to. And we've even had autism very, very positively affected. A lot. You know, what you got to do is start watching my videos about this, because very few people are talking about the really deep part of probiotics, which is fecal matter transplants. They wouldn't even allow them. And I still think they don't allow them in most cases unless you're ready to die. As soon as you're ready to die, I say, well, nothing we can do. I guess we're going to have to help them with the fecal matter transplant. That will help you on any disease that you have. Not only that, they have found that it takes old mice and makes them younger in every respect. That all the inflammations and all these different things they had before, gone. And guess what? They take from old mice, not even necessarily sick old mice, just old mice, the bacteria, and they replace the young mice bacteria with the old mice bacteria, and the young mouse has all the same effects that an old person has. So it's obviously the bacteria that is creating the environment for you to live a happy, healthy life, and that's your immune system. And it appears the bacteria ages just like the body of a person. And it could be that the body of the person ages just because the bacteria ages. It doesn't have the enzyme capabilities anymore to attack the invaders. So you have become what they call predisposed. What do they call it? There's preconditions. You're sick already, and it's just waiting for an invader. All right. So let's take a look at what she has to say. This should be very good. I hope it will be. But anyway, we'll find out. Okay, now this is on the CNN channel here, which they do a lot with new science.
So everybody, we have been caught for the last 2.5 years in this terrible situation where viruses have been the bad guy. But I'm here to tell you that the enemy of my enemy can be my friend, because viruses can be medicine. And I'm not just talking about any kind of virus today, I'm talking about the kind of viruses that attack bacteria. And my family had a personal close encounter with both of these. My husband and I were on a vacation in Egypt. We were having the time of our lives. He was hamming it up at the Cairo Museum, crawling through pyramids and things like that. Yeah, he was a little overweight, but he looked like he was in regular health. But a couple of days later, after we were having this wonderful meal on top of this cruise ship, he got violently ill. And I just thought he got food poisoning or something, and I was calculating the incubation periods for what kind of bug this could be. I'm an infectious disease epidemiologist, by the way. And, but it turns out it wasn't food poisoning. It was something worse. He had a gallstone that stuck in his bile duct and caused a small abscess, actually the size of a small football, to form. And he'd been walking around like this without knowing it. And while we were in Egypt, that abscess made a nice little apartment, or a superbug. He was medevaced first to Germany, where they diagnosed him inside this abscess with an organism called Acinetobacter baumannii. It's taken me years to...
All right, let me just make a statement. She's talking about him having a gallstone that caused a problem in his gut. That's what's called a pre-existing condition. Once you have lesions or cuts or anything that allows this invading bacteria to enter your good body, because you have a layer of what's called interstitium. It's a fluid-filled highway of bacteria that's good for you. That lays over the top of everything. They're membranes. Membranes coat everything in your body, and they keep the bad things out and they keep the good things in. Once you break through that membrane, you have a lesion, just like she said. Her husband got his lesion, and then he got sick. Now let's go ahead again.
He was medevaced first to Germany, where they diagnosed him inside this abscess with an organism called Acinetobacter baumannii. It's taken me years to learn how to pronounce it properly. But the World Health Organization estimates that this is actually the world's worst human pathogen of the bacterial nature, maybe after tuberculosis. And it's something of a bacterial kleptomaniac. It's really good at stealing antimicrobial resistance genes from other bacteria. And this is an organism I used to plate on my Petri dishes back in the 1980s at the University of Toronto. I was like, how could this, what used to be a wimpy bacteria, become something that's like, so deadly? Well, unfortunately, my husband became the poster child for this post-antibiotic era that we're entering right now. And it's estimated that by 2050, 10 million people per year, that's one person every 3 seconds, is going to be dying from a superbug infection. Now that's an estimated $100 trillion to the global economy through loss of productivity. Now, why is this? Why are we in this mess? Well, it isn't just misuse and overuse of antibiotics in medicine. Agriculture, we spend a lot of antibiotics on livestock, making pigs and cattle grow faster. But there's another problem too. The antibiotic pipeline is drying up because resistance is happening so quickly that farmers are saying it's just not worth making an antibiotic anymore. In fact, we haven't had any real new antibiotics in decades. They've all been riffs on old versions. So we're in a lot of trouble. And I started to realize that my husband was a lot sicker than I thought, and that modern medicine had run out of antibiotics to treat him. Because by the time he got medevaced home here to San Diego, we were actually in a really bad bind because this bacteria was resistant to every single antibiotic out there.
I want to make a statement about COVID right now. When she's talking about this particular bacteria was resistant, we don't have probiotics in our body for every single thing that pops up. COVID is a novel disease. Novel means we never saw it before. This guy here was going to die because we over here in the Western countries never saw this disease before. We have no immunity to it. So his body couldn't fight back. Now, what was it attacking? I don't know for sure, but it was attacking something very, very important to his life. What does COVID attack? This I do know. There's 28 different, at least, types of collagens in your body. Collagens are the membranes. COVID attacks a certain type of membrane. Let me show you something. All right, you see this? This is just 2018. Meet your interstitium, a newfound organ system in your body. And this is it right here. It runs in between your surface skin, your mucosa, or your intestines and so forth. And right in here is your immune system. And then in here is the stuff that gets invaded. If bad stuff can get through your skin from a break and then get through this and get into here, that's when you got trouble. Your good bacteria should be able to go back down in here because you're going to get cuts that are going to go into your flesh. That's just going to happen. It's just like these guys with these war wounds. However, your good bacteria should be able to come back down here and kill that stuff. It should never get through here normally unless you get cuts deep enough to get into this tissue. But if things are on your body all the time, these burn pit guys, and they have all these toxins on here, they just kill all the bacteria that's on here all the way down into here, and these try to fight back at it, and it just kills them. And then after that, they're wide open to invasion. Any little crack in the skin, boop, right in. Now, here's what happens with COVID. Hold on a second. All right, here's the story with COVID. It's never been seen before. All right, so if you have a pre-existing condition and you have a break in your what they call a mucosa, that's your skin, that's in your intestines, in your lungs, in your nose, in your lips, in your throat, in your digestive system, anywhere in there, you are breathing in these bacteria. If you get one of those bacteria in here and it finds a way to get through, then you're in trouble. If it just goes through your system, it goes through and goes out. And the reason is mucus is slime. Slime gets shot out when it finds out something is trying to invade you. That's why you inhale a bunch of particulates, you spit up a bunch of stuff, because your body makes slime to stop it from getting down into hurting you in this area. This is the area where all the bacteria lives. I'm going to show you a video in a second. It'll blow your mind. Now, what does COVID do? It breaks these collagen fibers. You see there's a little springy one, this brown one, and then you got a real floppy collagens. And they just stretch and they pull, and that's how you can move around, and they can pull this way, they can pull this way, and so forth. But the springs are locked down with a little tab, and the springs always open them back up again. Well, not once they get damaged by the COVID. COVID appears to change. I can't remember which collagen, but there's like a couple of major collagens. I think it's 3 and 5. I can't remember now. Maybe it's 1 and 3. I don't take that for any kind of... It's one of the collagens is getting broken down, and I believe it's this one. Now, because originally when I looked into this, the first autopsies they did, and I don't know why they never published much about it. I got sort of the back room information about it, which was that one collagen was being converted to another. That's what I heard. And the springy one obviously was getting converted to the floppy one because they can't open their lungs back up. I can't get air. Well, what do you got to do? You got to open the little alveoli in the lungs, and they're the same as these kind of things here. Not only that, the springiness of your blood vessels was collapsing, and blood vessels were collapsing because they couldn't open back up. Every time your heart pumps, you go boop, 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 of your every single. You know, that's why they feel your pulse. Obviously, the guy's still alive because he's getting a pulse. Well, when he gets a pulse, it springs open, closes, springs open, closes. That's what your heart does 24 hours a day, 7 days a week until you stop respirating, and then it's all over. Now, if we can keep bacteria in here from getting invaded and hurt and destroyed by antibiotics, because these are biotics, they're living probiotics. You kill them, you are in trouble. Let me show you what they found out about these actual areas of the interstitium. Brand new research. Okay, the name of this is called Your Textbooks Are Wrong. This is what cells actually look like. So they're just learning now, really, seriously, they're just learning about your body. And there is a lot of pushback because people feel offended that their knowledge is being overturned. Now listen to this. This is Gokul from, I can't remember where he's from. I think UC California or something like that. But this is from Seeker. All right, Seeker is the channel here, and it's called Your Textbooks Are Wrong. This is what cells actually look like. You should come up and watch this. Absolutely fascinating. Now watch just the beginning.
I still remember the moment. It's something I will never forget. The hair on my hands just stood up. It's a microscopic universe within each cell.
You see, that's one cell.
This is an unprecedented view of the cellular world, where we can actually see immune cells scooping up sugars in the ear of a zebrafish in...
I'm going to just make a statement in here. She's talking about scooping up sugars and so forth. Well, if this is a white blood cell, what this is scooping up, more than likely, is bacterias to go out and attack, or enzymes to go out and attack. It jumps right out of this immune cell with these things in its gut to deliver them. Now, is it mucus? Is it bacteria? I don't know, but I'm not sure it's sugars. They're talking. They just learned this. They just started. So let's go back and listen again. Here we go.
Actually see immune cells scooping up sugars in the ear of a zebrafish in real time.
Focusing only on the crawling immune cells, we've noticed two classes of them. One was not hungry at all, but it was very active in terms of trying to figure out, what the environment is. There's another.
All right, that first one you just saw a second ago. This one here is the one that creates.
Was not hungry at all.
The knowledge looks for that magnetic footprint. When it sees it, it communicates to the other bacteria and says, we need some certain type of enzyme up here to kill the thing that's coming in.
But it was very active in terms of trying to figure out, what the environment is. There was another one that was kind of slouching around with a lot of food in its belly. We can actually conceptualize and visualize and analyze the contents of each of these cellular compartments in this crawling immune cell as it's kind of, scooping up its environment.
All right, that's enough for you to see. You can come up and watch the whole thing. But what it's doing is each one of these is an immune cell. And this is the interstitium I just showed you. This is where all of this bacteria lives. And in the immune cells are the factories that produce the enzymes and mucus and all that. And this is the interstitium where all the bacteria are always, this is a layer that protects you. Up there is the bad stuff, down there is the good stuff. They squirt these things out, they go out and they attack the bad stuff. And another thing that enzymes do is they break down your food. So that they go out there and instantaneously, and I mean you couldn't even believe how fast they break things down. And they break it down so that you can absorb it. Don't make your food into tiny little molecules. You can't absorb it. It's pretty simple. Okay, let's get back to this lady here. She is an immunologist. She's a bacteriologist, something like that. And I work with other ones that are, they protect the food source coming into the country. I have a guy, he's got like 19 labs that they test foods coming into the country so we don't get these kind of things. This is really, it's not that complicated, but it's new. Things that are new seem to work at a glacial pace. Almost, it's just so much pushback instead of being curious. I just watched something last night about be curious, not judgmental. And that's what's happening is they're saying, oh, these great people don't know what they're talking about. Blah, 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 blah. We've been doing this for 50 years. Yeah, and everybody's dying now. So who's winning? All right, this is what I'm talking about, the magnetobacteria. And it says it's widespread. And really the whole thing here is it's enveloped by a bilipid bilayer membrane. This is where all that magnetic bacteria live. And then they go out and attack things. Magnetobacteria, magnetotaxis, they're starting to understand this. Okay, so we're back to Stephanie. Now we know about bacteria and how it works and enzymes and how they magnetically attach and all this stuff. So let's let her continue here.
He got medevaced home here to San Diego. We were actually in a really bad bind because this bacteria was resistant to every single antibiotic out there. And my colleagues at the University of California, San Diego, some of the best infectious disease physicians in the world, they turned to me and they said, you know what? He isn't going to make it. This photo was taken right after that. And I had this conversation that nobody ever wants to have with their loved one. And I said, honey, we're running out of time. I need to know if you want to live. I don't even know if you can hear me, but if you can hear me and you want to live, please squeeze my hand. And I waited and I waited. And all of a sudden he squeezed really hard. And I thought, oh great, my little blue gloved hand, I'm waving it in the air. And then I'm thinking, oh crap, like, what am I gonna do? I'm not a doctor, right? But I did what anybody would do. I went home and I hit the internet. And the National Library of Medicine has this wonderful free search engine called PubMed. You might have used it. And I put in the keywords for his superbug, antimicrobial resistance, alternative treatments, and I found this paper that mentioned something called bacteriophage therapy, or phage therapy for short, and it rang a bell. Because back in the 1980s, I took this rusty old degree in microbiology, and I learned that phages are viruses that have naturally evolved to attack bacteria. Now this is a scanning electron micrograph. It's blown up this bacterium 100,000 times, that's stained in orange, and attaching to it through its receptors are these little phages that look a little bit like alien spiders. Now, we know now that these phages are everywhere. There's a 10 million trillion, that's 10 to the power of 31 phages that are thought to be on the planet. They're everywhere.
Let me just make a statement. This is the magnetobacteria. They look for signatures to attack things. That's my belief. And it appears to be substantiated. Now here she goes. And this is what we need to do, is turn these bad bacteria against our bad bacteria. I mean, they're actually good bacteria for us. So anyway.
They're in soil, they're in water, in our oceans, they're in our bodies. They're actually the gatekeepers keeping our bacterial numbers in check. But you have to find the right bacteriophage to kill the bacterium that is causing the trouble. So there's the rub. How are we going to do that? Well, turns out you find bacteriophage wherever you find a lot of bacteria. Where do you find a lot of bacteria? Sewage. Oh my God. Sewage. Well, I thought, okay, you know what? Our back is up against the wall here. We're running out of time. Maybe we...
Obviously, that's a fecal matter transplant I've been talking about for years now. That's the only way you can repopulate your gut once it's been attacked. And it's attacked by antibiotics or enzymes that come from bacteria that live in other environments than we normally are in. So this guy was outside of his environment. He gets attacked, and there's nothing in his body to fight back. So we got to repopulate that gut.
We could find some phage to cure Tom. Well, it turns out that phage were discovered over 100 years ago, before penicillin was even discovered. But they were used then to treat bacterial infections, and they were taken up by the Soviet Union and used there as medicine. Now, in the 1930s, Soviets were, that was Soviet science. It was considered to be fringe. It got a really bad rub. So it was forgotten all about in the West, but has continued to be used till this day in the former Soviet Union and in parts of Eastern Europe. But it's considered experimental treatment in the US and Western Europe because the clinical trials to show that it works haven't been done. So I took this photo.
That's the key. They won't do the clinical trials. I've been pushing and screaming. I've been trying to get through to government officials, the VA. The veterans are dying, and they did our job, and now they're dying. And this is really annoying the hell out of me, that I can't get anybody to speak to me. And I just did a video. I had done a bunch of them on this burn pit stuff. Very, very distressing. And Biden's son died from exposure to these burn pits. And just like she said, other countries, what they're doing is using the Food and Drug Administration as a blockade to health, in my opinion.
A student had given us this T-shirt. I put it on Tom. I survived Iraqibacter. That was the unfortunate nickname for this organism because so many veterans came back from the Middle East with this organism in the late 1990s, early 2000s. And I wrote cold emails to total strangers begging them for help. And lo and behold, 2 teams came to the rescue with the help of the FDA and others. And one was from Texas A&M, and they actually turned their lab into a command center. And they took like barnyard waste and sewage and went through and took Tom's isolate and looking for the right phages for this phage hunt. And they found 4 that were a match. Meanwhile, we got the Navy involved. This guy who's a dead ringer for Tom Cruise, don't you think? He got his friend, the phage whisperer, as he's called, Dr. Biswas, and they found 4 phages that were a match, and they were sourced from the bilges of ships, believe it or not. I'm thinking, I don't care where they're from, as long as this will work. Well, nobody knew if this was going to cure him or kill him, but within 3 weeks, we actually had 2 phage cocktails ready to treat Tom. Now compare that to 10 to 15 years for an antibiotic to get developed, and maybe over $1 billion or more. So these phages were ready. We got FDA approval to treat him on a compassionate basis. And this is what Tom looked like. He'd been in the hospital now for 4.5 months. He was clinging to life. And I signed the consent form for kidney dialysis the day that we started phage therapy. And we just hoped and prayed that he was going to pull through. These are some of the doctors that cared for him, especially Dr. Chip Schooley, who was the head of infectious diseases at UC San Diego at the time. And we put the first phages from the Navy into his bloodstream and the phages from Texas into the catheters in his abdomen and just prayed. And 3 days later, Tom lifted his head off the pillow out of a deep coma and kissed his daughter's hand. Well,
You hear that? 3 days. fecal matter transplants can reverse your most serious conditions within 24 hours. My good friend was going to die 2 weeks later, and he didn't get a fecal matter transplant. He didn't get any of this really exotic, heavy-duty, real quick stuff. He just took probiotics. 2 weeks later, he was out jogging. He was in the same condition this guy was in. He's just ready to die. There's nothing we can do. We just go home and die.
Well, it was just miraculous. I mean, I'm telling you, but it gets better. Because he left the hospital actually 9 months after this whole journey began, wearing his Superman shirt. And then the story went viral. It was presented at the 100th anniversary of the discovery of the bacteriophage in Paris at the Pasteur Institute. And all of a sudden, people wanted phage for their family members that were dying from superbugs too. And of course, total strangers had stepped up to save my husband, so I wasn't going to turn them away. And we reinvented the wheel. We went to the same people, labs, found new labs who were going to help, and we saved some lives. Enough lives that our chancellor at UC San Diego gave us seed money to start what is now the first dedicated phage therapy center in North America, the Center for Innovative Phage Applications and Therapeutics, or IPATH. I co-direct it with Dr. Schooley, and the day that we opened, Science magazine published a commentary saying this is a game changer in the field. Well, thank you. So then we started publishing case reports. And there's been many other labs that have joined in. So Yale now has a phage therapy program, Baylor, Brussels has a phage therapy program, the Australians, Lyon, France, and more. But what we need now...
Let me just mention one thing. My friend, Marguerite O'Reilly, we treated her son with probiotics and a couple other little things. He was nonverbal autistic. They wanted to lock him in a padded room, literally, for the rest of his life. He was just so bad. He was way past 10 on a 10 scale. And now he's down to about a 2. And we did this 4 years ago, I guess we started. And the first thing I said to her was, how does he poop? And she said, oh, all autistic kids have trouble with their gut. And autism causes gut distress. I said, no, gut distress causes autism. I said, let's get that straightened out. And within, I don't know, it was within 3 weeks or so, he became verbal. Now, we never got any publicity or anything, but I stuck with her, and I'm still with her now. And she has actually gone to Harvard for ribosomes and all of that real deep inside the cell stuff. And now she is in Belfast, Ireland, and opening her own clinics. And she's helped literally, I guess, well over 500, maybe 1,000 people. And she's taking more and more on every day using the same very basic treatments. Now, they have phage therapy. Now we can really get somewhere. I didn't realize this has just popped into my feed today and blew my mind.
Are good stories. You know, we need to know, and we need to publish these. Well, here's Ella Balassa on the left-hand side. She has cystic fibrosis. My colleagues from Yale were able to source phage to treat her, and she's breathing them in through a nebulizer. And she just turned 30. On the right-hand side is Isabel Carnell Holdaway, a 16-year-old cystic fibrosis patient in England. And she was fighting Mycobacterium abscessus, a particularly nasty intracellular bacterial pathogen that's a cousin to tuberculosis. Now, student scientists from the C-Phages program, based at the University of Pittsburgh, sourced phage, one from a rotting eggplant in South Africa, believe it or not, and that was the only phage they could find. So they got these other sleepy phages, known as temperate phages, and they genetically modified them to become the phage rage kind that would kill Isabel's bacterium. And this became the first genetically modified phage cocktail to be successfully used to treat a human bacterial infection. It's gotten biotech really excited, and new biotechs and pharmas are moving into this space.
I want to mention something else. Archaeobacteria is a bacteria which was considered just in what they call extremophiles. They didn't think they had any real purpose. However, they live even in lava. Molten lava they still live in. Black smokers at the bottom of the ocean, they live in there. They live in every extreme condition there is. And now they are being looked at as the promoters of bacterial response. They are the big guns. They last forever. They literally, they appear you can't kill them. But if you don't have them in your body, you don't have these directors. And that's what they're looking at now. I'm very excited now. I can't help myself. This is just amazing. I didn't realize anybody was paying any attention to this.
One of the more exciting stories that we just heard this year is about a young woman who was a victim of the terrorist attack in Brussels a couple of years ago. And if it isn't the most terrible thing, living through a terrorist attack like that, she actually had shrapnel that embedded in her leg, and she got a superbug infection. She was treated for almost 3 years with antibiotics, and it kept coming back, and she lost the ability to walk. My colleagues in Brussels developed a phage cocktail through directed evolution, treated her, and she's cured. She just is walking now. So it's just remarkable, these stories. But you know, we need more than just case studies. We need clinical trials. That's the only way that the FDA is going to approve phage therapy. And I'm glad to tell you that the NIH has supported phage therapy trials through the Antimicrobial Resistance Leadership Group, a research network of institutions around the US. They're about to launch the first multi-center trial of phage therapy, and we're involved just right up the street. So it was slowed down due to COVID, but it's about to launch, so we're going to be reporting on those results fairly soon. And for all you angel investors out there, we need next is a phage library. We don't want to have to go from bog to bedside every time we need phages, right? We want to be able to go to a walk-in cooler and source those phages that are characterized and cataloged and personalize them for patients. So that's what I'm fundraising to do next. Now, there's many other applications of phages because we need a multi-pronged approach to be able to treat antimicrobial resistance.
I want to say something right now before I forget. As I said, my friend Andy does the food safety. And they don't use phages, but they just test them if it's nobody's going to get sick. However, there's something else I want to talk about. All right, this is someone who is involved in the glyphosate research. Stephanie Seneff, PhD, MIT senior research. Now, The Silent Spring was a book by Rachel Carson's I read long ago. Now, we have a toxic legacy, and what's happening is they're using this glyphosate, which is Roundup, to kill all the weeds, and then they can plant right into that same soil. But the glyphosate is still in the soil. Now, they say it won't hurt you, it only hurts plant life. Well, guess what? The things that are in your body that are your bacterial saviors mimic plant life. So, what we need to do is see, is that glyphosate damaging our bacteria? I don't care about damaging your skin cells or damage your eyeballs. I want to know, does it damage the bacteria? Because you're not having enough of this glyphosate to kill all your bacteria, but you're going to have enough probably if you eat a lot of GMO foods. Genetically modified foods means that they change the food itself to not die. So they can plant food where they killed everything else, but the food takes up that toxic substance, and then it gets into your body. Well, they say, well, that won't hurt you. They cultured cells and so forth, apparently. I don't know what they did to make that claim, but I don't care if it hurts mammalian cells. I care if it hurts bacterial cells. All right, so let's go back to this other one. You know, I want to make this exactly what she says. These ingredients in the world's most commonly used weed killer responsible for debilitating chronic diseases, including autism, liver disease, and more. And I actually corresponded with Dr. Seneff years ago about this. And we didn't really get too deep into it, but she agreed that it's destroying the bacteria in our body. Now, one other thing I want to mention, I almost forgot, is that some of the vaccines that the kids get when they're young, those attack things in your body to make you get a response so that your body will remember if you see these things again. Well, guess what? Some of those things can literally cause autism and so forth. The MMR vaccine was the one I was talking to her about, and she agreed that that appears to have some impact on autism. Now, my recommendation is probiotics absolutely before and after any inoculations. Okay, here we are back to the other Stephanie.
And the other problem is that COVID has actually made the superbug crisis worse. There's misuse of antibiotics because of the fear that COVID is going to lead to secondary bacterial infections. And so we've really got to move on this, because this is the next pandemic, and it really is already here. Now, my husband and I
like I said, COVID attacks your collagens. That's what I'm taking away from this. Now, she has input to a whole bunch of people that can really do the research, and I hope she'll watch this, or I hope I can communicate with her somehow.
realize that we are so privileged. I mean, this started out being the worst thing that could ever happen to somebody, but it's helped other people. And since I'm an infectious disease epidemiologist and I was blindsided by the superbug crisis, we decided to tell our story and to make it public. We published our book, The Perfect Predator: A Scientist's Race to Save Her Husband from a Deadly Superbug. Now, we have a lot of people to thank for our story. People that I haven't even met. I certainly didn't do this alone. But I've got to tell you that there's one person that has changed medicine, and it's Tom Patterson. Honey, stand up. Ladies and gentlemen, may I present to you life itself. Thank you very much.
Amazing.